So let's look at another form for quadratic functions. So we have our standard form, which we just looked at, where it's the ax squared plus bx plus c. Now in this form you can actually still see a here, that would be the same value, but then how the rest of it is organized, we can't see b and c anymore. But what we can see is the vertex. So the vertex is showing up as values here, and it's coming from h and k. So h gives us our x coordinate, and k gives us our y coordinate. And then you can look at a for how we used it in the last video in terms of if it's concave up or down. Again, it would have the shape of concave up if a is positive, concave down if a is negative. Now, something to pay attention to is in the vertex form, next to h, we expect to have subtraction there. But then when we move to vertex form, like if h is a positive number here, so let's say we had y equals 2x minus 3 squared plus 4, something like that. We expect the subtraction to be there, so when we grab our x coordinate, we would use positive 3. And then the value for k is your y coordinate, so we would just grab 4. So something I keep in mind with the vertex is that what we see in the vertex form, switch the sign of x, or at least how it kind of looks there. You're going to switch that, but then keep y the same. So if that helps, just remember, if you have subtraction, x coordinate will be positive. If we had addition there, then the x coordinate is going to be negative, and we'll look at that in our example here. So, alright, we have a function here. Looking at this, I can see I have an a of -3. So we're going to have a concave down case. I could already get an idea of the shape of the parabola. For the vertex, this would represent h equals, and then because it's showing the addition symbol, it would actually be a -2, and k is positive 3. Alright, so first thing we're asked for is our y-intercept. So for the y-intercept, we want to plug in 0 for x. So we're going to look at f of 0. So plugging in 0 for x, so 0 plus 2 squared plus 3. And then we're going to simplify. So first thing, parentheses, so -3 times 2 squared plus 3. Then I have the exponent, so -3, 2 squared is 4. Multiplication. And last step, -12 plus 3 is going to be a -9. So this will have the coordinate x equals 0, y is -9. Alright, vertex is going to be easy here because we just grab our values. So we're going to have the coordinate h, which is -2, and k, which is positive 3. Writing the factored form, so we want to get to our x-intercepts. And actually, okay, 2 ways to go about this. And since we looked at the factored form in the last video, where we factored it as we're used to, I'm going to show a slightly different way here. But because the idea is for our x-intercepts, we want to take our function and set it equal to 0. So the long way that we could go about that is multiply out the x plus 2 squared, distribute the -3 in there, add 3, and you'd get your trinomial, you'd get your standard form, and then you could factor it like we did in our last video. So it would take simplifying all of this into standard form and then factoring. But let me show you a way of solving without actually having to expand that x plus 2 quantity squared. So I'm going to skip the factored form and just use the form that we were given. So I'm going to plug in 0 for f of x, and then I'm going to have negative 3 times x plus 2 squared plus 3. So what I want to do with this is completely isolate this x plus 2 squared onto one side of the equation. So isolating our variable, or in this case kind of isolating an expression, we take care of addition and subtraction first. So I want to get that plus 3 away from there, so I'm going to subtract 3 from both sides. So I'm going to have negative 3 equals negative 3 times x plus 2 squared. Then I'm going to get that negative 3 away from the x plus 2 squared, so I'm going to divide both sides by negative 3. And with that, we end up with positive 1 equals x plus 2 quantity squared. Now what I'm going to do is take the square root of both sides. I want to get rid of that exponent of 2, and I can do that by taking the square root of both sides. So that on one side of the equation, so that x plus 2 squared with the square root, the root and the exponent will cancel out, so we'll just have x plus 2, and then equals the square root of 1, but what we need to keep in mind is when we take the square root of both sides of the equation, we always get a plus or minus. Only time we drop the plus or minus is if we're working with a word problem where negative outcomes don't help us. So plus or minus square root of 1, which is just 1. Then I'm going to subtract 2 from both sides to completely isolate x. When we do this, it's helpful to have this negative 2 first, so putting the plus or minus between the two values. So how I'll write this is negative 2 plus or minus 1. And then we end up with our two cases. X equals negative 2 plus 1, or x equals negative 2 minus 1, which will give us x equals negative 1, or x equals negative 3. So this method, while we're not as practiced with it, is a lot faster than doing what I described up here, where we would expand, distribute, simplify, and then go through and factor it and solve. Here you can work a little more directly with it. You just have to isolate the expression with the exponent, take the square root of both sides. You can't forget your plus or minus, that's incredibly important. And then you'll end up with your two solutions, which in this case is the coordinate negative 1, 0 and negative 3, 0. All right, so with that, we have a y-intercept, a vertex, and some x-intercepts. Now these values are pretty nice and small, so I'm going to go ahead and use a scale of 1 here. So our intercept, 0, negative 9, is all the way down here. Negative 2, positive 3 for our vertex. And then x-intercepts of negative 1 and negative 3. Now if it helps, like I was mentioning in the last video, you can imagine this axis of symmetry going through the vertex. So if we wanted another point, we could actually use the y-intercept. We could see it's this distance of 2 away from the axis of symmetry. So what we could do is get another coordinate that would be over there. So sometimes it can just help to have that. If you don't graph it, it's not the end of the world, but it can be helpful for a little more guidance for graphing the parabola. All right, so our parabola will go something like this. Pretty narrow, concave down, going through those coordinates. And then, as you see from our axis of symmetry, we'll have x equals, and it's just the x-coordinate of our vertex, which is negative 2. Let's jump over to the graphing calculator and see how these values come out there. So I'm going to use the Desmo Scientific Calculator. Instead of typing in f of x, I'm going to type in y, so y equals, and then my equation of the line, so negative 3 x plus 2 squared, and then plus 3. If you ever get trapped up in the exponent there, just hit the arrow button to the right, or you can use the mouse to click down, I'll get out of that exponent. So what we could do is use this to check that we graphed everything correctly. And what's nice is that it will highlight the points that we focused on. So our x-intercept, so you have our -3 and -1, you can kind of click them to highlight them. If you don't want to see them anymore, you just click them again. Our vertex, there's our -2, 3, and then we can see we're crossing at 0, -9. So with Desmos, it's nice because it gets you to really pinpoint those key values, and then you could check that you graphed everything correctly.